Azlan Adnan, M.A. presents Antlers of Ambition, a provocative tale of science fiction exploring research ethics, unintended consequences, and the price of ignoring the precautionary principle. In the spring of 2027, beneath the ceaseless glow of Singapore's ultramodern skyline, Dr. Liora Chen stood motionless before a towering holographic genome map that rotated silently in the sterile air of her laboratory. The facility, situated on the edge of the sprawling Bioforge district, represented the pinnacle of Southeast Asia's biotechnology revolution. Towering arcologies housed research complexes where artificial intelligence merged seamlessly with human cognition, and the humid tropical atmosphere was filtered continuously through antimicrobial membranes and autonomous environmental systems. To the outside world, Dr. Chen was a scientific celebrity. To her peers, she was both admired and feared. A prodigy trained at the intersection of synthetic biology, developmental genetics, and neuroregenerative science, she wielded tools of unprecedented precision. Base editing enabled her to rewrite individual nucleotides with surgical accuracy. Prime editing allowed highly targeted insertions and deletions without creating catastrophic double-strand breaks in DNA. More importantly, her laboratory had pioneered the use of adaptive synthetic promoters, engineered molecular switches capable of activating genes only under highly specific biological conditions, including hormonal surges, seasonal circadian shifts, and epigenetic thresholds associated with puberty. These technologies had originally been developed for medicine, cancer suppression, tissue regeneration, congenital disease correction. Liora intended to use them for something else entirely. For nearly a decade, her research had centered upon the extraordinary regenerative biology of antlers in sika deer. Unlike horns, antlers represented one of the fastest examples of mammalian organ regeneration known to science. Every year, they emerged from the skull with astonishing speed, supported by dense vascular networks, accelerated osteogenesis, rapid chondrogenesis, and highly organized keratinization. Then, just as remarkably, they detached and regrew again in a repeating cycle governed by hormones and environmental cues. To Liora, antlers represented something profoundly important, not merely ornamentation, adaptability, renewal, directed evolution. Most scientists interested in human cranial modification had focused on permanent horn structures derived from bovine or caprine developmental pathways. Horns were biologically simpler. Once grown, they remained fixed for life, but Liora rejected that approach almost immediately. Permanent horns, she believed, would doom any modified human to permanent social segregation. Antlers offered something different, a cycle, a possibility of concealment. During periods of annual shedding, the modified children could theoretically move through society unnoticed. They could attend schools, form friendships, sit in cafes, walk through shopping districts, and exist without immediately becoming spectacles of public attention. Then, during the regrowth phase, they could withdraw temporarily into specialized residential facilities until the antlers matured fully. It was, in her mind, a compromise between transformation and normalcy, a biological rhythm balancing individuality and assimilation. At least, that was the theory. The subjects of her experiment were a cohort of 23 orphans, wards of the state with no surviving familial claimants. Officially, they had been enrolled in an advanced pediatric wellness and neurodevelopment program funded through Bioforge philanthropic initiatives. In reality, they constituted the first human trial of directed cranial evolution. Liora selected them with meticulous care. Their genomes were screened exhaustively for autoimmune stability, audacious integrity, hormonal predictability, and low oncogenic susceptibility. Artificial intelligence models simulated thousands of possible developmental outcomes before a single edit was performed. Even then, the probabilities remained uncertain. Human developmental biology was not software. It resisted control. Within sterile surgical suites illuminated by soft blue operating lights, Liora isolated hematopoietic stem cells from the children's bone marrow. Using multiplexed CRISPR arrays, she introduced coordinated edits into the BMP, WNT, and RUNX2 signaling pathways, all of which governed bone patterning, cranial outgrowth, and tissue density. Additional modifications targeted angiogenic regulators to support rapid vascularization during antler formation. But the most radical innovation lay in the temporal control system. Synthetic promoters synchronized gene activation with seasonal hormonal fluctuations. Melatonin cycles, testosterone surges, growth hormone peaks, and circadian oscillations were all integrated into a carefully engineered biological clock. The antlers would emerge only during specific developmental windows and regress annually through programmed osteoclastic resorption. The children would not simply grow antlers, they would molt them. By age 11, the first changes appeared. Small, hardened ridges developed beneath the skin near the temporal bones. Initially, clinicians mistook them for benign cranial thickening. Within months, however, the nodes elongated into distinct structures supported by dense vascular networks visible beneath the skin as faint branching capillaries. The growth process was painful. The children described sensations of deep internal pressure, accompanied by migraines, low fevers, and auditory hypersensitivity during peak growth phases. Yet the structures themselves were undeniably magnificent. They were not delicate deer antlers, nor were they crude animal horns. They represented something entirely new. The formations emerged as thick, elegantly ridged cranial antlers, curving upward and backward from the skull in smooth, symmetrical arcs. Their surfaces displayed subtle texturing resembling polished obsidian, layered with organic striations. Under certain lighting conditions, embedded photonic nanostructures introduced during the keratin engineering phase produced a faint iridescent shimmer. The media became obsessed almost immediately. Global networks referred to them as the horned generation, despite the structures technically being regenerative antlers rather than permanent horns. Holographic billboards across Singapore displayed stylized silhouettes of the children against futuristic skylines. Scientific congresses hailed the achievement as the beginning of post-human adaptive evolution. Liora became the face of a new scientific age. Governments courted her. Corporations offered billions in licensing agreements. Religious organizations denounced her. For a brief moment, however, the children themselves experienced something dangerously intoxicating: admiration. Crowds gathered simply to glimpse them. Interviews described them as beautiful, transcendent, evolutionary pioneers. Some of the younger children even began competing playfully over whose antlers would grow largest during each seasonal cycle. Then the shedding phase began. The first detachment occurred in late December of 2028. One of the younger boys, Elias, awoke screaming as microfractures propagated silently through the antler base during natural osteoclastic separation. By morning, one structure had detached completely onto his bedsheets, slick with blood and tissue fluid. Within days, all 23 underwent shedding. Liora initially celebrated the event as proof her regulatory systems worked exactly as intended. For several months afterward, the children appeared outwardly normal again. Residual scarring remained hidden beneath hairlines. Public attention diminished rapidly. Some attended conventional schools under confidentiality agreements. Others wandered anonymously through crowded transit stations and shopping centers for the first time in years. Liora believed she had succeeded. Then the regrowth cycle returned, and with it came reality. The transitions themselves became impossible to conceal. Early-stage regrowth caused visible cranial protrusions beneath the skin, drawing immediate scrutiny. Social media users circulated photographs relentlessly. Parents complained to schools. Rumors spread online describing the children as unstable, contagious, unnatural. Public fascination transformed into apprehension, then hostility. Educational institutions cited structural safety concerns. Employers refused internships. Insurance providers classified the children as biologically anomalous high-risk individuals. Viral conspiracy theories claimed the antlers enhanced aggression or neurological instability. The children learned quickly that society admired transformation only at a distance. Up close, difference frightened people. Worse still, medical complications emerged that no predictive model had anticipated. Microfractures developed during accelerated growth spurts. Altered cranial weight distribution produced cervical strain and chronic headaches. Several subjects exhibited vascular asymmetries, resulting in transient visual disturbances. One girl developed autoimmune inflammation attacking the antler tissue itself, causing agonizing necrosis during shedding periods. Psychologically, the damage ran deeper. The annual cycle fragmented their identities. For part of the year, they could almost pretend to be ordinary. Then the antlers returned, and the world reminded them they were not. Friendships dissolved. Romantic relationships became fraught with fetishization or fear. Some withdrew entirely from society during growth phases, refusing even digital communication. Inside her increasingly restricted laboratory, Dr. Chen immersed herself in data. Holographic displays flickered endlessly with terabytes of genomic analytics, epigenetic drift patterns, and neuroendocrine simulations. The more she analyzed the system, the clearer the truth became. The edits had not remained isolated. They had propagated subtly across developmental pathways, influencing immune regulation, stress responses, even social cognition in ways no algorithm had fully predicted. The human genome was not modular. Every alteration echoed through interconnected systems. Attempts to reverse the process failed repeatedly. Removing the edits destabilized adjacent regulatory sequences. Suppressing growth triggered dangerous inflammatory cascades. In 2 cases, experimental reversal therapies accelerated uncontrolled bone proliferation along the jaw and cervical vertebrae. Liora stopped sleeping regularly. The woman once celebrated as humanity's evolutionary architect now wandered her laboratory at 3 a.m., surrounded by silent holographic projections of skeletal models rotating endlessly in the darkness. For the first time in her life, she understood the true danger of technological capability. Not malice, not incompetence, certainty. She had believed precision equaled wisdom. She had mistaken the ability to alter biology for the ability to predict consequence. By 2031, public opinion had shifted decisively. Bioforge executives distanced themselves from the program. International ethics tribunals demanded investigations. News networks quietly stopped mentioning the horned generation altogether, as though silence itself might erase collective discomfort. But the children remained. Now young adults, they continued living within the rhythms Liora had imposed upon them. Each year, the antlers emerged again from their skulls in elegant arcs of bone and keratin. Each year, they shed them once more, and each year they endured the strange liminal existence between visibility and concealment, neither fully accepted nor fully hidden. On humid evenings overlooking Singapore's glittering skyline, their silhouettes occasionally appeared against the illuminated horizon, figures with antlers curving upward and backward beneath the neon haze of the future city. Living reminders, proof that scientific power, unconstrained by humility, eventually ceases to ask whether something should be done and concerns itself only with whether it can be done. And in that narrow gap between capability and wisdom, Dr. Liora Chen had rewritten not merely the human genome, but the lives of 23 children who would carry her ambition upon their heads for the rest of their lives.